Good morning, Danny. It is March 21st, and yesterday was the first day of spring. Which I'm sure to somebody that means something, but here in San Francisco, we don't really have seasons. But I'm sure to you in, like, gross Washington, means something. Hey, Danny, how's that gross rain working out for you? I don't know if you saw Google's doodle yesterday, but it was adorable. Or doodable. Nah, I know, I'll leave. It's fine. And B, it talked about the vernal equinox. Now, Danny, Webster's defines the vernal equinox as the... Just kidding, I'm not going to define it like that because I'm not a 5th grader doing a book report. Although, sometimes I do act like a 5th grader. Equinox, besides being super fun to say, comes from the Latin meaning equal nights. Vernal just means something related to springtime. There's also an equinox in the fall called autumnal. So let's put it all together. You have a time in the spring when the length of the day equals the length of the night. Neat! So now is the time when the days actually start to be longer than the nighttime. Which means that beaches and embarrassing suntans are just around the corner. And I bet I know what you're thinking, Danny. Except I need to make a little interjection. I'm not at my house, so I don't have Imposter Danny, but you know what I do have?
Boy, I'm so glad that our planet has an elliptical orbit so that we can be closer to the sun during the warm months of the year.
Oh, well then I would just call you big dumb fat stupid face. Our orbit around the sun doesn't actually have anything to do with the fact that we have seasons here on Earth. Like, for example, okay, I'm gonna make a fire here in San Francisco, and then you tell me when you can feel the heat there in Washington. Just let me know. I'll wait here. The point is, that would take a really long time. And the distance, it's not gonna make a big difference if I make the fire bigger by a lot. You may recall from a science class that you've taken in the past that our planet has a really cool special feature. It has a tilt. The Earth has an axial tilt, fancy word alert, or obliquity, of about 23.4 degrees. Now it's actually this axial tilt that causes our seasons, not our distance to the sun. Okay, disclaimer, yes, our distance from the sun has some effect on our temperature, but it's not the kind that you're thinking of. This average distance from the sun is what causes our temperature to be a little more than something like Neptune or Uranus. However, it's not the only factor in things. Like Venus is actually the hottest planet in our solar system, not Mercury, even though Mercury is actually closer to the sun. So why does the axial tilt actually cause our seasons? I'm going to demonstrate with this giant Pokeball and a flashlight and my friend Xander. So as you can see, as I rotate the Pokeball and you have the flashlight pointing at it, the northern hemisphere is staying lit a lot of the time, whereas the southern hemisphere isn't, and that's why it's winter in the southern hemisphere, and then summer here. And so as this tilts, this is going to be about spring, this is going to be about summer. So there you have it, Danny. Seasons. Now you know how they work. Good luck with your climb, and I will see you on Monday.